This is Algebra Lesson 1-9, Patterns, Equations, and Graphs. We're going to start with quite a few vocabulary words, which review a little bit about the coordinate plane as well before we walk into this particular lesson. A coordinate plane are two numbered lines that intersect, otherwise known as a Cartesian coordinate plane. You have a y-axis and an x-axis. They intersect and they give you four quadrants. The x-axis is your horizontal axis, and your y-axis is your vertical axis, the axis that goes up and down. The origin is the point where the axes intersect, which is at the 0, 0. So right here, that would be your origin. The quadrants are the four sections that the coordinate plane is divided into, and quadrants are always labeled with Roman numerals. Starting in the upper right, this would be quadrant 1, this would be quadrant 2, down here is quadrant 3, and last but not least, this is quadrant 4. Always listed with Roman numerals, never using Arabic numerals, which is the way we normally write numbers. An ordered pair is a location of a point. Sometimes an ordered pair can be written as a 2, 3. You always put a comma between your x-coordinate and your y-coordinate. The coordinates are the numbers of that point. The ordered pair is the location, and the coordinates is the numbers that give you the location. A solution of an equation in two variables x and y is the ordered pair x and y that makes the equation true. Okay? And inductive reasoning is the process of reaching a conclusion based upon an observed pattern. It's different from deductive reasoning because it's based on observation, where inductive reasoning is observation. Deductive reasoning is based on rules and things that you can establish and show are true or false. So let's start with working on a little bit of stuff about the coordinate plane. As again, here's a coordinate plane. Here's my x-axis. That would be my horizontal axis. My y-axis is my vertical axis. You should always label them if they're not labeled. I've labeled quadrants 1, 2, 3, and 4. And we're going to give the coordinates of points. So if we look at point A, you always start at the origin, which is your 0, 0 point here. We always read left and right first, and then up and down second. So if we go to point A, we're going to go to the right 6 units, and we're going to go up 2 units. So the coordinates of point A is 6, 2, because we go right and left, and then we go up and down. You don't go up and down first, you go right and left first. So point B, again, you start at your origin. Point B is 2 units to the left and 1, 2, 3, 4, 5 units up. So it's a -2 and a +5. Now we're going to talk about quadrants. What quadrant is point C in? We look and we find point C. Point C is here, which is in quadrant 2. So we are just going to say that it is in quadrant 2. Then we look for point D. If you look for point D is here. Point D is not in quadrant 3 and not in quadrant 4. In fact, it's on the boundary line between quadrant 3 and quadrant 4. So we don't say it's in quadrant 3 and we don't say it's in quadrant 4. We actually say which axis it lies on. It happens to land on the y-axis, so this is on the y-axis. Because something cannot be in 2 quadrants simultaneously. It could be on the boundary line between the 2 quadrants, which would be one of the 2 axes, but it can't be in quadrant 3 and quadrant 4 at the same time. All right, now to determine if an ordered pair is a solution to an equation, you can simply substitute the values into the equation to see if it makes a true statement. That's the easiest way to determine if something is a solution. So let's take a look at this. It says, is the ordered pair a solution of the equation of y equals 4x? Remember, the ordered pair goes in the order of x and then y. So 5 is x and 20 is y. So if I plug this into the equation, y equals 4x, I get 20 equals 4 times x, which is 5. And 20 does equal 4 times 5. So yes, 20 is a solution to this equation. Let's do the same thing with the other points. So we're going to have here, we're going to have y, which is -20, is going to equal 4 times -5. -20 equals -20. So yes, -5, -20 is also a solution to this equation. If we look at letter C, we have -20, -5. So -20, whoops, that's x, not y. Y is -5. negative 5 is supposed to equal 4 times negative 20. Well, negative 5 does not equal negative 80, so this would be a no. And letter D, 1.5 and 6. So 6 equals 1.5 times 4. I don't know why I put 1.4. Let's do that correctly. It would be 4 times 1.5. 1.5 times 4 is indeed 6, so 6 equals 6. So yes, this is a solution to this equation. Now, you can represent the same relationship between two variables in several different ways. And it's good to know how to do them in every way. You will find you'll have your preferences as to which way you like best, but it is good to know more than one way to solve something, because sometimes solving it one way is easy for one problem, but makes it more difficult for a different problem. So let's say we have a problem here. You have 4 more left socks than you have right socks. And if you have socks like my husband, his are actually labeled right and left. So how can you represent the relationship between the number of left and right socks in 3 different ways? Well, we could make a table. I could let the number of right socks be X and the number of left socks be Y. So if I have 4 more left socks than right socks, no matter how many right socks I have, I'm going to have 4 more left socks. So if I have 4 right socks, I have 8 left socks. 5 right socks, I have 9 left socks. 6 right socks, I have 10 left socks. 7 right socks, I have 11 left socks. 8 right socks, I have 12 left socks. Way number 2, I can do an equation. Well, we already know if we let X equal number of right socks, we always want to define our variables. You'll find that out really soon when we get into the next chapter. Let Y equal number of left socks. And I know that no matter how many right socks I have, I always have 4 more left socks. It's always 4 greater than the number of right socks. So left socks is always 4 greater than the right socks. So how do I write an equation for that? Well, left socks is Y, so Y is going to equal my right socks. It's because the left socks is always 4 greater than the right socks, so it's the number of right socks plus 4. So there's an equation to model that particular event. And the last thing we can do is we can do a graph. Okay, here I have some nice graph paper, so I'm going to label some things. These would be my right socks because that was my X. These are my left socks. It's a little bit harder for me to write sideways. Because I hit things. Well, I'm going to go by ones. If you go by anything other than ones, you have to label. You have to label your X and Y axis. Okay, so if I was going to count by 2s, I would have to count 2, 3, 4. Okay, this is 0. This is 1, 2, 1, 2. I don't have to label much more than that. So if I go by my table here, if I go back to my table, if I had 4 right socks, I had 8 left socks. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. If I had 5 right socks, I had 9 left socks. If I had 6, 2, 4, 5, 6 right socks, I had 10 left socks. If I had 7, I had 11 left, and if I had 8 right, I had 12 left. I can see a little pattern here, and I can definitely see this is linear, so I'm going to actually draw a line for these. I need to make sure that I have, my line is that way, and I want to make it purple. See how well I can draw my line today. So I can expand this, and then I can make some predictions on how many socks I had. Okay, and the last thing I should do is I should always label my graph. This is left versus right socks. So these are three different ways to represent the same relationship between left and right socks. One is with a table, one is with an equation, and one is with a graph. The graph is obviously very visual, the table is fairly visual, and the equation is very linear. So depending on what you might like one thing versus another. Let's practice a couple more. It says you can use inductive reasoning to do some predictions. So we're going to use some inductive reasoning here. It says the table shows a relationship between the number of chairs and the total number of legs. Extend the pattern. What is the total number of legs on 10 chairs? Well, if I look at this, I'm looking at this and I'm seeing, every time if I have one chair, because X is the number of chairs and Y is the number of legs. So this would be chairs and this would be legs. So if I have one chair, I have 4 legs. If I have 2 chairs, I have 8 legs. 3 chairs, 12 legs. 4 chairs, 16 legs. 5 chairs, 20 legs. It looks like the number of legs is always 4 times the number of chairs. The number of legs is 4 times the number of chairs. So if I wanted to make an equation, therefore, these 3 dots like that mean therefore. Therefore, legs, which would be my y value, is going to equal 4 times the number of chairs, which is my x value. Okay, so then it says, what is the total number of legs on 10 chairs? So y is going to equal 4 times 10, which is 40. So there will be 40 legs on 10 chairs. And this was done inductively because we were looking at a pattern. Okay, so we have 2 things here. There's my equation. Okay, and then there's my answer. All right. All right, the question of the day for today is, what is true of a graph of an equation that is a straight line? What is true of a graph of an equation that is a straight line? Please answer that at the end of your notes.